Hi everyone. This lesson is a quick review about Venn diagrams and the way we use them for describing relationships between different sets of objects. So the rectangle is usually referred to as the universal set, which means everything, at least everything in the current context of what we're thinking about. And the little symbol epsilon is used to represent the universal set. Now, inside the universal set, there could be subsets of different objects. So we might have set A and set B, which are things with different characteristics. The way I've drawn these here, we can highlight something interesting about them. So the little part here where they overlap, this would be objects that belong to both set A and set B. So you might see it written as A and B. It's also referred to as the intersection of the two sets. And mathematically, we would symbolize that by using a little upside down U shape. And that's actually called a cap. So there's three different ways of saying the same thing. We could say A and B. We could say A intersect B symbolically there, or we could say intersection of A and B. And that's what that is. Now let's have a look at a different relationship that we could have. Again, we could have set A, we could have set B. Now, what if this time we're interested in an object or an element that belongs to set A or B? What would I have to shade in? Well, I'd shade in pretty much all of those, wouldn't I? I'd more or less join the two sets together into one much larger set. Don't forget to put epsilon in the corner to represent the universal set. So A or B, written like that, could also be the union of the two sets, the union of A and B. And symbolically, we write A with a little U and then B. So you could see the union of two sets represented in any of those three ways there. Mathematically, the symbol would be A intersect B or A union B. And if you think that this is something that I sort of did when I was beginning to learn this, that looks a little bit like the letter N, which is in the middle of the word and. You'll always remember that and means the intersection or means the union. Now that's not the only thing. Those are two very important things. There are other relationships that we need to know about sets. So let's have a look here. That could be set A. Let's have set B again and the universal set. Now, what if this time I shade everywhere except set A? So I'm trying to make sure that everything is shaded outside set A. So notice those ones don't go there. There it is. Now, what's that? Well, that's the complement of A. It can be symbolized with A as a dash. I've also seen it written as a horizontal line above the top of the set like that, meaning everything that except what's in set A. Of course, I can have the complement of set B if I wanted to. Now, I can have, what else can I have there? Intersection, unions, and complements. What about a subset? Here we go. This will be interesting. What if I have set A there, and then I have set B here, and then I might even have down here set C and then the universal set. Now, what would I say here? Well, I would say that A is a subset of B. And that's that same little symbol, but on its side. So this is a subset. In fact, it's a proper subset because A looks like there's less elements in A than there is in B. So A is a subset of B if everything that is in A also belongs to B. Now you might wonder why we bother having set A if it's entirely contained within set B. Well, let's have an example. What if in this instance here, A represents albatross B is birds, and C is cats. So there are, of course, every albatross is also a bird. That's why A is a proper subset of B. But there could be birds like pelicans or magpies over here that belong in set B, should not be in set A. And of course, set C being cats, we would say that set C is disjoint. Set B and C are disjoint. They have nothing in common. That's just another phrase. That's probably about enough for a quick review of Venn diagrams and set notation. Thanks for watching.